Welcome back, folks. We're getting a couple new components today. So I want to talk about briefly, very briefly, how we classify different components. These are going to be new passive elements, and I've been talking about the passive sign convention, and the only passive element we've had so far is the resistor. The other two components that are passive are the capacitor and the inductor, and we're going to figure out how to analyze circuits using those components. So let's start out with this whole setup I got here. The resistor is passive, mostly because it provides no power to the circuit. It can only dissipate power. It can't add power to it. So stating that a little more formally, up in the corner there, we can see that it says that it contributes no power gain amplification to a circuit. So it's not amplifying. There's no control action, so it's not a switch. It's not turning on and off parts of the circuit, which some active elements do. And it doesn't require any input to function. It's a resistor. You put a voltage across it, current's going to flow through it. Something similar is going to happen with a capacitor and inductor, a little bit different, but very similar. And those components fit that classification. Okay, they don't add energy to the circuit. Active elements, going for the flip side of this, they're capable of controlling voltages and currents. So those are going to be your semiconductors or your electromechanical components. Switching is certainly an electromechanical type of phenomena that we're going to see a little bit in when we talk about transients. But that's later, and those are going to be active components, not passive. And they can't amplify a circuit. The op-amp can, right? That's really the only one that we've looked at so far that has some ability to make a signal bigger or add energy to the system. Okay, the other thing that we have to talk about is kind of subdividing these passive elements. Okay, so let's see here. And we can talk about storage elements. And while they can't add energy, okay, to the circuit, they can store that energy. Okay, kind of implied by the name, right? And two of our passive elements end up being storage elements. Okay, so the resistor, the capacitor, and the inductor, I made a little table here so that we can talk about classification. Those are all passive. Okay. And then the voltage source, current source, and op-amp are all active. They can add energy to the circuit somehow. Within the passive elements, okay, can't add energy, so these must be passive if they can't add energy. The capacitor and the inductor can store energy. The capacitor is going to store energy in an electric field, and the inductor is going to store energy in a magnetic field. So we can kind of break that down further. The resistor can't store energy. All it can do is turn it into heat and dissipate it into the atmosphere. Okay, so we're getting two new elements, capacitor and inductor. Those are going to be separate videos. I told you this one would be short. And you've probably run into these elements in your physics courses, which are prereqs to this course. I'm going to reintroduce them, talk about physical properties briefly, but really what I want to do is focus on what's important about them as it relates to performing circuit analysis. How are we going to perform circuit analysis around capacitors and inductors? I want you to be able to analyze any circuit, and that includes any circuit that has a capacitor and an inductor included in it. Okay, so I think we're starting with capacitors. That's coming up next. Stay tuned and good luck.